Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at the principle of operation of a two-stroke engine. Well, to begin about the discussion of a two-stroke engine, first let's define what a stroke is. A stroke is actually the movement of the piston from its lower end to the upper end. This is one definition of a stroke. So when the piston is undergoing only two strokes, one forward and one backward stroke, in order to produce power, that type of engine is called a two-stroke engine. For example, this engine will only require two strokes in order to produce power. For example, when piston is moving up from its lower position to the TDC, when it is moving up, it will admit in air-fuel mixture into this cylinder, and by the time it reaches TDC, it will ignite the air-fuel mixture by use of a spark, and then that will force the piston assembly to go down. As it moves down, it will remove the exhaust. So only two strokes is required. One forward stroke and one backward stroke will be sufficient to generate power. That is why we call this type of engine a two-stroke engine. Now let's have a look at some of the main components of this two-stroke engine. Right here we have the carburetor. The carburetor is there to mix air and fuel with a certain quantity so that we can have a combustible mix submitted to the cylinder. So the carburetor is there to meter and supply metered air fuel into the cylinder. Now, in order to control the amount of air fuel mixture that is going to be supplied to the engine and therefore control the engine speed, right here we have a throttle valve. The throttle valve is now closed. For example, you can open it by simply turning it in such a fashion. So by simply turning the throttle knob, you can open. Now, for example, the entire passage is open, so maximum air fuel mixture from this carburetor will be supplied to the cylinder. So this is used to control the volume of air, the mass of air getting into the cylinder, and hence that will help to control the engine speed. So right here we have the carburetor. Air will come in this way, fuel will be supplied. This is the float bowl for keeping a constant amount of fuel. That constant amount of leveled fuel will be sucked based on the amount of air that is passing. When much air is passing, much fuel will be intercepted and that will supply to the cylinder. When only a small amount of air is passing, that will suck only a small amount of fuel from this venturi, and that will supply the engine with small amount of fuel, so the engine speed will be smaller. And engine speed is controlled by this throttle valve. As you can see, this opening is wider and smaller depending on the position of the throttle valve, and this is what you use in order to accelerate this two-stroke engine. Fuel from here will be supplied to the intake manifold, and as you can see, this intake port is covered and uncovered by the piston. The exhaust port is also covered and uncovered by the piston itself. As you can see, there are no mechanically operated valves. Instead, we have ports. This is what makes two-stroke very simplified. Because the ports are covered and uncovered by the piston itself, there is no need of additional valve, crank, all that timing assembly. So by simply uncovering and covering the valve, the passage of the intake port by the piston, there is no need of using valve, so that will make the two-stroke very simple in construction and lighter weight as well. And when you look at the piston, right here we have the piston. The head of the piston, it has a cowl or a deflector for directing the incoming air fuel mixture, and this part is tapered in order to guide exhaust to pass to the exhaust port. So the piston has this type of shape. This is called the deflector, sometimes known as a cowl, and connecting rod is there to connect the piston to the crankshaft. The crankshaft has a counterweight. As you can see, this is a counterweight that is moving in opposite direction to the travel of the piston. When piston is moving up, this is moving down. When piston is moving down, this is moving up. They are always moving in opposite direction. So this will be used to dynamically balance the crankshaft as it is rotating. Now, when piston and connecting rod are moving up, this will move in opposite direction, balancing the entire assembly. So dynamic balance is maintained by simply using a counterweight that moves in opposite direction to the travel of the connecting rod and piston assembly. Now, let's have a look at how it is operating. Let's begin by assuming that the piston is moving up. When piston is moving up, as you can see, just concentrate on the blue color. How much blue color you are watching. Look at the blue color. Now when piston is moving up, out of the crankcase, as you can see, the blue volume is increasing. Volume inside the crankcase is increasing. Now this increasing volume will have a suction effect because piston is moving out of the crankcase, piston is withdrawing itself from the crankcase. That will cause a volume to increase in the crankcase. As you can see, the blue volume is increasing. When blue volume is increasing, pressure will reduce. Piston moving out of the crankcase will have a suction effect in the crankcase. So as piston is moving out, that suction will suck air fuel mixture from the carburetor into the crankcase. Air with fuel will be supplied to the crankcase. Now for this type of engine, because there is no dedicated lubricating system, small amount of oil is also added to the incoming air fuel mixture to lubricate the moving parts, lubricate the cylinder walls, lubricate the connecting rod. All these components will get lubricated by oil that is added to the incoming fuel. Now, because the piston has moved up, forward stroke, crankcase volume has increased, air fuel mixture will get admitted into the crankcase. Now the piston, once it reaches TDC, it will start to come down. Now look what is happening to the volume of the crankcase. Look at the entire blue color as piston is moving down. When piston is moving down, as you can see, volume is reducing inside the crankcase. So the piston is pressing down on the air fuel mixture that is admitted into the crankcase. That will pressurize the crankcase, and pressurized air fuel mixture will pass through this transfer passage. It will get admitted into this cylinder. So this is how air fuel mixture is transferred from the crankcase into this cylinder. Incoming piston will pressurize the crankcase, pressing down the air fuel mixture that was already trapped in here. And because the piston has now closed the intake passage, there is only one way of the air fuel mixture to travel. It will come up this transfer passage and then get admitted into the cylinder. Then when the piston starts moving up again, it will start to close all the passage. Now air fuel mixture is admitted, piston is moving up. As you can see, transfer port is closed, exhaust port is also closing. Further travel of the piston will compress the air fuel mixture that is already admitted. Now the piston has approached TDC. When the piston is near TDC, the compression will have this maximum compression pressure inside the cylinder because the red volume is decreased. Air fuel mixture is now compressed to this very tiny space. Spark will be initiated. Spark will be supplied by the spark plug as air fuel mixture is already compressed. Now when the spark is supplied to the already compressed air fuel mixture, that will cause explosion inside the cylinder. A very fast chemical reaction will take place. This is a very high exothermic chemical reaction that exerts massive pressure on the piston. That explosion will force the piston down. Look, piston will be forced down by that expansion of the combustion gas. When piston is moved down, as you can see, let's bring it back a little. When piston is moving down until the exhaust port is opened, we have the power stroke. We have power because the combusted air fuel mixture is forcing the piston to travel down, increasing the cylinder volume, and that is the power phase. As the piston moves further, it will uncover the exhaust port. Now exhaust port is opening. Some residual pressure is here inside the cylinder from previous combustion. Once it is uncovering the exhaust passage, that residual pressure will remove majority of the exhaust from the cylinder. That is why we always have some pressure at the exhaust. There is residual pressure. The pressure will not be zero. It is some small quantity of pressure is there that will remove majority of the exhaust. Now, when we are removing exhaust from this side, further travel of the piston will uncover this transfer port. Fresh air fuel mixture is getting admitted into the cylinder. So, majority of the exhaust will be removed by the residual pressure. If there are any remaining exhaust particles, that will be removed by the incoming fresh air fuel mixture. The fresh air fuel mixture will move to this direction. It will swirl due to this deflector. It cannot directly pass to the exhaust. Rather, it will swirl. It will become dense. Then it will move further, removing if there are any remaining exhaust gases that will be forced out by the fresh air fuel mixture. Now, once the exhaust is removed and fresh air fuel mixture is admitted, piston will start to move up again. Now look what will happen to the red color when piston is moving up. Now fresh air fuel mixture is admitted into this cylinder. As piston is moving up, look at what is happening to the red volume. Red volume is decreasing. As piston is moving up, red volume is decreasing, which indicates air fuel mixture is getting compressed to a narrow space. This compression will generate heat and pressure. Now the already compressed air fuel mixture will then be ignited by spark. The spark will initiate a very fast exothermic chemical reaction that will cause a massive explosion inside the cylinder, and that is the one that is going to force the piston down, exerting pressure, force on the connecting rod, crankshaft, and finally to the whatever applications that you want the engine to do. So this is how the two-stroke engine compresses and develops power. The downward travel, the backward stroke, partly is used for power. Until the exhaust is opened, we have power. Immediately as it is uncovering the exhaust will begin, and after a little while, transferring air fuel mixture, fresh air fuel mixture into the cylinder will commence. This is how it is operating. Compressing, then producing power, moving down, exhausting, transferring fuel, moving up, compressing. So every time the piston reaches TDC, we have a compressed air fuel mixture and we have power to be supplied. Every time the piston is reaching TDC, we have power. So one forward stroke and one forward stroke and one backward stroke is sufficient to generate air fuel mixture, to generate power in this two-stroke engine. So that is why we call it a two-stroke engine. Only two-stroke is required to generate power. Now there is some drawback on two-stroke engines. As you can see, there is a time where transfer port and exhaust port are simultaneously open. Now this will make small quantity of unburned fuel, raw fuel, to escape with the exhaust. So that is why these two strokes are not fuel efficient. Why? The overlapping period of this opening will make some quantity of air fuel mixture to escape to the atmosphere. That will cause wastage of fuel. So two-stroke engines generally are not fuel efficient due to this fact. That is why they are not popular in car engines. Rather, they are popular in small engines, lightweight engines, because when the engine is very small, the quantity of fuel to waste is very small. So that is what makes two-strokes not to be popular on car engines, due to their reduced fuel efficiency. There is wastage of fuel. There is some quantity of fuel to be wasted as a result of this overlap. So this cycle continues until the engine is turned off by disconnecting spark. Unless spark is interrupted and it runs out of fuel, it will keep on running, just doing this entire process over and over again. When piston is moving out of the crankcase, fresh air fuel mixture will be admitted to the crankcase. When it is moving down, it will supply. Then it will remove previous exhaust. Fresh air fuel mixture will be admitted. Moving up will compress it. Ignition will take place. Then power, exhaust, all this cycle will continue unless spark is interrupted or fuel is interrupted. So this is basically the principle of operation of a two-stroke engine. Now, as you can see, it is air-cooled. Majority of them are air-cooled. You see these fins. Fins are there in order to cool the air. Air will be used in order to cool these engines. As you can see, it is finned. Fin will increase surface area. The heat of combustion will be distributed to all this volume. That will cause heat dissipation to the atmosphere, so they are air-cooled. Because of lack of dedicated another cooling system, rather than simply using fins, This will make this type of configuration lightweight. So two-stroke engines are lightweight. There are no many moving parts. As you can see, only these are the moving parts available. And this will reduce the entire weight of the two-stroke engine, and cost of manufacturing is also reduced. So basically, this is the principle of operation of the two-stroke engine. A spark will be supplied by a dedicated ignition system and contact point. As you can see right here, there is a contact point that will be triggered by the crankshaft itself. Every time the piston approaches TDC, it will trigger a spark, and that is how ignition is initiated on this type of engines. And this will have a magneto that will drive spark for generating electricity for the ignition system as well. So this is basically the principle of operation of a two-stroke engine. We have the inlet port and the exhaust ports to be covered and uncovered by the piston itself. And there is an intermediate transfer port that is also opened by the piston itself. So this is basically the principle of operation of a two-stroke engine. They are lightweight, easy to manufacture, easy to carry around. This is basically the principle of operation of a two-stroke engine. Well, dear viewers, that is all we have for you regarding the principle of operation of a two-stroke engine. If you find this video helpful and if you enjoy what has been presented, please smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.